The Colorado Stormwater Council and the City of Colorado Springs have developed this culvert lining training as a method to deliver educational information to municipalities and developers across the state of Colorado. We will offer a quick introduction of our specialists and then we'll jump right in.
My name is Alan Vanderweerd. I'm a construction manager with Basis Partners. We are a consulting engineering firm headquartered in Colorado Springs. We do a lot of work with City of Colorado Springs and CDOT.
Josh Lubert with American West Construction. I'm the project manager on the Culvert Rehab project down here in Colorado Springs. We are a utility and heavy civil contractor that works with different municipalities, developers, and CDOT in all regions across the state.
Alan, so how do you identify culverts that need repair and grading? And how do you prioritize based on the damage you find?
Typically we'll use our in-house rover, which is a robotic inspection tool we use to assess the inside of storm pipes. We use a grading system that we've come up with to give a numerical quantity to help identify which pipes are on the low end of the spectrum, which ones are on the high end, so we can prioritize funds. So a lot of the things that we do during our inspection is we'll identify corrosion, cracks, obvert damage, invert damage, tie-ins that protrude too far or not enough. From there, once we have a full report over to them, they can determine if they believe that it's in poor enough condition or good enough condition, whether it needs a repair or not, based on our recommendations.
Thanks, Alan. So what software besides the FHWA software do you use for your inspection data?
So most of our software is something that's been adopted by City of Colorado Springs. It's called Cartograph. And it's there's several out there similar to it, but this is the one that they've kind of decided to work with. And what that does is it maps and inventories all of the city's assets inside of there. Every asset has sort of a profile that shows a photo, material type, sizing, everything like that. And then within there, we can also assign tasks to all of our inspectors for inspections, repair tasks. And we're able to actually track not only the work that's being done on all of these assets, when the last time work was done, when it was installed, but also track money and budgets and funding. So you could actually you could draw a section of the city and say how much has the city spent in this part of the city on pipe assets compared to other parts of the city. The other thing that it does really well is once we put in our ratings, it'll actually take that information and it'll project a lifetime expectancy for that asset based on the material type, when it was installed, what kind of repairs were done. And every time we do an inspection, it'll update that. And so in the future, once all that data is collected, it'll actually ping city employees saying, hey, this asset is actually coming close to its life expectancy. And this is something you might want to go check on. Because obviously, the biggest concern we have with storm pipe assessment is public safety. So if one of these assets is nearing the end of its life and it's expected to fail soon, that's hazardous to the community. And so you may not have a program in place to inspect that asset, but with this software, it'll give you a heads up, hopefully, before that catastrophic event happens.
What is the typical length of a project and what's the typical cost?
A lot of our pipes, especially in Colorado Springs, they'll vary a lot. We do a lot of laterals and main lines, but typically the average length is around 150 feet. So they're not long projects usually. And then the per unit cost per foot is usually around $240 or so. And that's going to vary a lot depending on, diameter, length, location of the pipe, how much cleaning is involved with it prior to having to line it. We've also found that if we can actually group a lot of these pipes together when we're ready to line a few of them, we can actually get a better price from contractors because then they're able to come down, mobilize one time for all of them, group them together, and then we're not getting individual prices for all of them. So that's been a really cost-effective way of getting lots of different work done all at once.
Thanks, Alan. So are you using the pipe assessment certification process by NASCO?
We've used PACP by NASCO quite a bit, and it's a good tool to help identify in a very quick way what is actually happening in a certain section of storm pipe. But what it really doesn't do very well that we've found is give some kind of a numerical, quantitative assessment of that storm asset. And so we'll do a 0 to 10 scale of the full asset so that we can know very quickly, looking at that rating, if a pipe is in good condition, let's say a 6 or a 7, or if we potentially have to do a repair where it's a 3 or a 4. And then from that point, we can look at the PACP and see exactly how far down that pipe the actual damage is. Our engineers can take a report that has NASCO PACP documentation on it and have a very quick idea of where damages are, what kind of tie-ins are happening on that pipe. So it's sort of a combination of using the traditional PACP and sort of a tailored rating system ourselves.
Alan, during construction, how do you identify issues that could lead to failure?
We have inspectors in the field that will look for various things to make sure that the product is being applied correctly and that it's meeting all the criteria that it's intended to. So they'll typically send in submittals describing exactly the characteristics of the material, lining thickness that's been determined by a professional engineer. So the biggest thing that we look for is ensuring that the material is meeting the strength and thickness that it's intended to. So a few ways to check the thickness. Obviously you could go in with a tape measure and just measure thickness that way, but that could leave you vulnerable in the middle sections because it's really difficult to measure before and after diameters, things like that. What we often will do is we'll sink in screws through the pipe, and we'll set them at the depth of the liner, so we know that once those screws are covered by liner that they've hit their intended thickness, and that's particularly useful on a spray type application. In terms of a CIPP impregnated type of liner application, that's a little bit simpler because when it comes out, the manufacturer already has a thickness sent in. So we just do a couple of checks, make sure that the right liner was sent to the job site. And as long as it's looking good at the initial application, there's really not a whole lot that could go wrong with liner thickness. In terms of verifying strength, that's really difficult to do in the field. So what we'll typically do is collect a few samples. We partner with several testing firms around the state, and they have the ability to do compressive strength breaks on those to check that they're meeting the compressive strength goals. And then for CIPP, we'll take a sample, the final product hardened liner, and send that in, and then they'll do the whole tensile, compressive, and flexural strength tests on those. Based on those results, we'll have a conversation, pass or fail with the contractor, and go from there. Occasionally, if it fails, if it becomes low on strength, on a spray type application, they could do more layers. We could do pay reductions have been done in the past to just ensure the city's getting, or the state, whichever entity, is getting the product that they're paying for the value that is intended to be there. The other things inspectors will look for is just typical construction activity, ensuring BMPs are in place, traffic control is in place, permits are in hand, ensuring that stormwater quality is not compromised during any of the process, since most of the projects are happening in waterways or near waterways. We always want to ensure that those environments are being protected at all times. And then once the liner is applied, the big thing that we check at that point, once we're satisfied, is making sure all the tie-ins are in good condition, that there's no way water is going to undermine where the liner ties into an inlet or flared end section. So if there's not a good watertight connection, we'll just have them maybe trim it a little bit and grout it. Typically some epoxy grout will suffice for something like that.
So Josh, what are the most common installation processes?
There's three types of installation processes we have been doing over the past many years in different municipalities and for different CDOT regions. The first one is a slip line method, and that's basically taking the hose pipe and inserting a smaller diameter pipe on the inside and grouting the annular void in between. We've just wrapped up a project last year doing this up at the top of Wolf Creek Pass. We've done it up I-70. Is it a good application where there's a lot of water that needs to be dealt with? We are able to get the water running back through the pipe fairly quickly after it's installed, so the clean water bypass phase of the project is very minimal. The second process is the spin cast method Alan was talking about. That is cleaning a pipe and then applying a cement water mixture liner to the inside of the pipe. This is spun on using a sled and a pneumatic sled to apply the liner. As Alan mentioned, we use screws to verify the depth to ensure that we've met the requirements set forth by the engineer. Third one that we're doing right here in downtown Colorado Springs right now is a UV cure method, and that is taking a epoxy resin liner, inflating it inside the hose pipe, and then using a light train to UV cure the pipe. After it's cured, we'll trim the pipe, grout the inverts if needed at the entrance and exit, and walk away.
Thanks, Josh. Can you tell us what the benefits to existing infrastructure are?
The big one is the low impact to the general public, the environment, any of that. It's a fairly low impact process. We can get in and get out with what we're doing down here on Castilla Street right now. It's a day process. We show up, we jet and TV first thing in the morning. The guys come in, roll the liner out inside of the pipe, and then we cure it. Aside from a day of traffic control, there's really no interruption.
When is lining not an option?
Lining can be difficult on pipes that have large bends or different imperfections with them. We've ran into this issue on a 24-inch line just across town here, where there was two approximate 22.5-degree bends where we couldn't even safely run a camera from either direction without potentially losing it. At that point, trying to get a liner through there just doesn't work. One option would be to dig that up and try to line it from both directions, but because we are trying to have a low impact on the infrastructure in the area, that just wasn't feasible on this one. So there are a few things, but usually we're able to line a lot of the pipes.
Thanks, Josh. So does the ambient temperature place restraints on installation? And what is the best season to install?
Right now is a perfect time. Water's running low, so dealing with clean water bypass or dewatering activities is usually minimal. The temperature for specifically like a UV cure can go both ways. When it's too hot, the liner wants to cure just by the rays of the sun. Adversely, if it's cold, it is not pliable and doesn't want to unfold and slide in very well. On the spin cast method, if it is colder out, we are able to add heat to the pipe to allow the cement to cure properly, so not a huge issue. But on the flip side, if it is too hot, it will try to set up in the hoses quickly and creates problems in its own right there.
So Alan, what are the rate of inspections after the project is complete?
So typically we'll do warranty inspections after, let's say, a lining is done. That's usually 2 years afterwards. In terms of annual or anything like that, after a repair is completed, we usually expect, as long as everything looks good after the warranty period, that the life expectancy of that asset is going to be over 50 years. And so basically once a repair is completed, that kind of goes into our good pipe asset inventory, and the bad ones get brought to the top of the list. And so typically we will kind of put those on the back burner of inspections, knowing that, you know, a good repair has been completed on them already.
What are the confined space entry protocols, and
Yep.
Do you ever have any air monitoring
Yep.
pings that
Yep.
stop you from working?
We do.
All of our crews carry air monitors with them when they go down into a confined space as laid out by OSHA. So prior to entering a confined space, they'll test their air monitor, make sure that it's operating correctly, test the air before they enter in 3 spots. They'll also call a local fire department emergency evacuation team and just let them know that where they're going to be working and for how long, just in case something were to happen. Then if they don't get a call back within an hour or so, they'll dispatch a crew to check on them. What we've started to do a lot more when we do our inspections is actually deploy our rover. So we can have an inspector on the surface operating it from a monitor, and they won't have to do any kind of confined space, and we can do all of our inspections that way. So we've started using that a lot more, especially just from a safety aspect. There have been a few times when we've had inspectors down in a storm pipe where the air monitor goes off, and that is typically due to vehicle traffic on the surface. So if you're actually in a heavily congested area with a lot of cars idling nearby, the emissions coming out of that vehicle will settle down into the storm pipe, and that will cause the air monitor to go off. In terms of safety during construction, we follow all those same confined space protocols, and then we also verify that everybody on the site is wearing appropriate PPE, not only the air monitors, but also helmets if they're down in the pipe, or hard hats, vests, safety toe boots, everything that most municipalities and state agencies require of them.
Josh, you want to add anything?
Yeah, our guys will use different underground hard hats when they're in pipes with chin straps, that sort of thing, to, you know, the traditional hard hats don't always work when you're crawling around in pipes. Our guys carry air monitors, check everything before they go in, from the TV crew at the very beginning to the TV crew at the end after everything's done. So, yeah, safety is number one when going into those pipes.